Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from group 3 and the material that will present is about the assumption, the normal distribution, homogeneity, and linearity. Before we present, I will introduce our members. The first one is me, Siti Nur Aziza, second Aulia Azahra, and the last Zahwa Karunyawati. For the first explanation, I will explain myself about normality. What is assumption of normality? Assumption of normality means that you should make sure your data roughly fits a bell-curve shape before running certain statistical tests or regression. You've got two main ways to test for normality: eyeball a graph or run a test that's specifically designed to test for normality. The data doesn't have to be perfectly normal. However, that definitely does not meet the assumption of normality is going to give you poor result for certain types of tests. Using a graph for a normality test, a Q plot compares two different distributions. If the two sets of data come from the same distribution, the points will fall on a 45-degree reference line. To use this type of graph for the assumption of normality, compare your data to data from a distribution with known normality. Box plot. Draw a box plot of your data. If your data comes from a normal distribution, the box will be symmetrical with the mean and median in the center. If the data meets the assumption of normality, there should also be few outliers.
The next is normal probability plot. The normal probability plot was designed specifically to test for the assumption of normality. If your data comes from a normal distribution, the points on the graph will form a line. As you can see that line on the graph on our PPT.
Okay, I will continue the next explanation about histogram. Homogeneity of variance and ANOVA assess homogeneity of variance when comparing three independent groups on a continuous outcome. The assumption of homogeneity of variance is the second statistical assumption that needs to be tested for when comparing three or more independent groups on a continuous outcome with ANOVA. Homogeneity of variance is assessed using Levens test for equality of variances. In order to meet the assumption of homogeneity of variance, the p-value for Levens test should above 0.5. If Levens test yields a p-value below 0.5, then the assumption of homogeneity of variance has been violated. And the next is homogeneity. Homogeneity of variance essentially makes sure that the distribution of the outcomes in each independent group are comparable and or equal. If independent groups are not similar in this regard, spurious findings can be yielded. ANOVA should not be conducted on continuous variables that violate the assumption of homogeneity of variance. ANOVA should only be conducted on continuous outcomes between groups that have equivalent or similar variances. So the next explanation will continue
Okay, next is linearity. Linearity means that the predictor variables in the regression have a straight line relationship with the outcome variable. If your residuals are normally distributed and homoscedastic, you do not have to worry about linearity. You can check multicollinearity two ways: correlation coefficient and variance inflation factor (RVIF) values. To check it using correlation coefficient, simply throw all your predictor variables into a correlation matrix and look for coefficient with magnitude of 0.80 or higher. If your predictors are multicollinear, they will be strongly correlated. However, an easier way to check is using VIF values, which we will show how to generate below. You want these values to be below 10.00, and best case would be if these values were below 5.00. To fully check the assumption of the regression using a normal PP plot, a scatter plot of the residuals, and VIF values, bring up your data in SPSS and select Analyze. After that, regression and linear. Set up your regression as if you were going to run it by putting your outcome or dependent variables and predictor or independent variables in the